In the relentless pursuit of fully reusable rockets, SpaceX has conquered challenge after challenge. But there's one final obstacle standing between them and their ultimate goal: the heat shield. These ceramic tiles, all 18,000 of them, have been the Achilles heel of reusability. Like delicate dinner plates strapped to a rocket experiencing intense vibrations, they're prone to cracking, expanding, and contracting under extreme temperatures. But Elon Musk just revealed something that's about to change everything. In a recent tweet that caught the attention of the entire aerospace community, he made a bold declaration: SpaceX will achieve a fully reusable heat shield by 2025, with the technology perfected by 2026. While some dismiss this as typical Musk optimism, those who've been following Starship's development closely noticed something different this time. Hidden in his November announcement was a crucial detail that points to a revolutionary shift in spacecraft thermal protection. The metal heat shield is making a comeback. Yes, you heard that right. SpaceX is reviving and revolutionizing a technology that NASA once explored, but never fully realized. With Flight 7 on the horizon and nearly 50 heat shield tiles mysteriously removed from Starship's surface, we're about to witness what could be the most significant breakthrough in spacecraft reusability since the Space Shuttle program. Welcome to Elon Musk 24 Hours. Let's dive right in. The story of spacecraft heat shields is written in scorch marks and sacrifice. Every successful mission, every safe return, has come at the cost of discarding expensive components. A price tag that's been accepted as the cost of reaching for the stars. But SpaceX has never been a company to accept conventional wisdom. To understand the magnitude of what SpaceX is attempting, we need to step back and look at what makes thermal protection so challenging. When a spacecraft re-enters Earth's atmosphere, it faces temperatures that would melt most metals. The air molecules hitting the vessel's surface create a plasma envelope hot enough to vaporize steel. This inferno of physics has been one of spaceflight's greatest challenges since the dawn of the space age. The current solution on Starship might look simple: 18,000 ceramic tiles covering its belly like scales on a dragon. But these aren't your ordinary kitchen tiles. Each one is a technological marvel, capable of withstanding temperatures that would turn sand to glass. Yet, as Elon Musk pointed out with characteristic frankness, you've got a whole bunch of dinner plates stuck on the side of a rocket that's shaking like hell. It's not just the heat they have to contend with, it's the violent vibrations, the extreme temperature swings, and the physical stress of atmospheric re-entry. The ceramic tiles are remarkably similar to those used on NASA's Space Shuttle, but with one crucial difference. The shuttle's tiles were custom-shaped for each specific location on the vehicle, a meticulous approach that meant replacing even a single damaged tile could take months. SpaceX revolutionized this by creating standardized hexagonal tiles, making manufacturing and replacement far more efficient. But efficiency isn't enough when you're aiming for rapid reusability. This brings us to Flight 7, where SpaceX is making a bold move that's raised eyebrows across the aerospace industry. Nearly 50 heat shield tiles have been removed from Starship's surface. To the untrained eye, it might look like a step backward, but those who've been following SpaceX's development know better. This could be the first test of something revolutionary. Enter the metal heat shield, a concept that sounds counterintuitive at first. How can metal, which can melt, protect against temperatures hot enough to melt metal? The answer lies in one of the most ingenious cooling systems ever devised for spaceflight. Back in 2018, Musk first hinted at this technology, describing what he called a stainless steel sandwich. Picture 2 layers of steel with a network of tiny channels between them, almost like the blood vessels in your body. Through these channels would flow either fuel or water, creating what engineers call a transpiration cooling system. As the liquid seeps through microscopic perforations in the outer layer, it creates a protective barrier against the intense heat of re-entry. But SpaceX isn't the first to explore metal heat shields. In the 1990s, NASA and Lockheed Martin were developing something remarkably similar for the X-33 Venture Star program. Their design used a sophisticated honeycomb structure made of Inconel 617, a superalloy capable of withstanding temperatures up to 2,000 degrees Fahrenheit. The system was elegant in its complexity, a metallic shell encapsulating internal insulation, maintaining panel shape while supporting mechanical loads. The X-33's metal heat shield underwent extensive testing, including high-speed wind tunnel evaluations and real-world trials mounted on NASA F-15 aircraft. The results were promising. The system could protect against temperatures approaching 1,800 degrees Fahrenheit, while being relatively easy to install and remove. But when the X-33 program was canceled in 2001, this groundbreaking technology was shelved, becoming another what if in aerospace history. Now SpaceX is breathing new life into this concept, but with modern technology and manufacturing techniques that weren't available 30 years ago. The advances in materials science, computational fluid dynamics, and additive manufacturing since the X-33 era mean that what was once impossibly complex might now be not just possible, but practical. The potential benefits are staggering. While metal heat shields might be more complex and initially more expensive to manufacture than ceramic tiles, they offer something priceless: true reusability. No more replacing cracked tiles after every flight. No more painstaking inspections of thousands of individual components. A metal heat shield, properly designed and implemented, could withstand multiple re-entries with minimal maintenance. SpaceX's approach might not be all or nothing either. The company could create a hybrid system, using metal heat shields in the areas that face the most extreme conditions during re-entry, while retaining ceramic tiles in less critical areas. This would balance cost and performance while providing valuable real-world data for future improvements. The timing of this development is crucial. With Starship preparing for more ambitious missions, the need for a truly reusable thermal protection system becomes more pressing. Each flight provides new data, new insights, and new opportunities to test and refine these technologies. The removal of those 50 tiles on Flight 7 isn't just a test. It's a glimpse into the future of spaceflight. Think about what this means for the future of space exploration. A fully reusable heat shield isn't just about saving money or improving efficiency. It's about fundamentally changing how we think about spaceflight. When you don't have to replace critical components after every mission, space travel becomes more like air travel. Turnaround times shrink from months to days. The cost per flight plummets. The doors to regular, reliable space access swing wide open. This is where SpaceX's unique approach to innovation shines. While others might see the current ceramic tile system as good enough, SpaceX sees it as a stepping stone to something better. They're not afraid to revive and reinvent old ideas, to challenge conventional wisdom, or to risk failure in pursuit of breakthrough success. The Metal Heat Shield project represents everything that sets SpaceX apart in the aerospace industry. The willingness to question established practices, the courage to attempt what others deemed impossible, and the persistence to keep pushing until they succeed. It's not just about solving a technical problem. It's about removing one of the last major barriers to truly reusable spaceflight. As we watch Flight 7 prepare for launch, we're not just watching another test flight. We're watching the potential dawn of a new era in spacecraft design. Those missing tiles might look like gaps in Starship's armor, but they could be windows into the future. A future where spacecraft return from the edges of space ready to fly again, protected by shields that don't just survive re-entry, but thrive through it. What SpaceX is attempting here goes beyond mere technical innovation. It's a testament to the power of refusing to accept limitations, of looking at old problems with new eyes, and of having the courage to try what others have abandoned. The metal heat shield isn't just a solution to a technical problem. It's a symbol of how far we've come and how far we might yet go in our journey to the stars. As Flight 7 prepares to test this revolutionary approach to thermal protection, we're witnessing more than just a technical evolution. We're seeing the future of space travel take shape. SpaceX's metal heat shield isn't just about surviving re-entry. It's about making space truly accessible. Each breakthrough brings us closer to a world where rockets launch and land as routinely as aircraft, where the dream of regular space travel becomes reality. This is the kind of innovation that defines SpaceX, taking abandoned ideas, breathing new life into them, and pushing them beyond what anyone thought possible. The missing tiles on Starship aren't gaps in its armor. They're stepping stones to the future. Want to stay updated on this groundbreaking development and other SpaceX innovations? Join our growing community of space enthusiasts by subscribing to Elon Musk 24 Hours. Hit that like button if you're excited about the future of space travel, and share your thoughts about metal heat shields in the comments below. Together, we're watching history unfold, one technological breakthrough at a time. This is Elon Musk 24 Hours, bringing you tomorrow's space technology today. See you in the next episode. In 2002, a small warehouse in El Segundo, California, became the birthplace of what would become the world's leading space company. For over 2 decades, SpaceX and California seemed inseparable, a partnership that transformed both the state's aerospace industry and humanity's reach for the stars. The million-square-foot Hawthorne facility, once home to Boeing's 747 production, became the heart of SpaceX's innovation, where Falcon 9 rockets and Dragon capsules took shape. But today, this long-standing relationship faces its greatest test. In a move that sent shockwaves through California's tech landscape, Elon Musk has decided to relocate SpaceX's headquarters to Texas, following in the footsteps of Tesla's earlier departure. This isn't just another corporate relocation. It's a seismic shift that signals deeper changes in America's tech industry landscape. The story behind this move reveals a complex web of factors, from political tensions and regulatory challenges to the promise of new horizons in the Lone Star State. For California, losing one of its most valuable tech assets raises serious questions about its future as a tech hub. For Texas, it represents a triumph in its bid to become America's next frontier of innovation. Welcome to Elon Musk 24 Hours, where we bring you the latest developments in Elon's ventures and innovations. In today's episode, we'll take you behind the scenes of this historic move, explore its far-reaching implications, and uncover what this means for the future of both states and the American space industry itself. Let's dive right in. The story of SpaceX in California began like many great American dreams, in a humble warehouse where a team of visionaries dared to reimagine the future of space travel. By 2007, that dream had outgrown its original home, leading to the acquisition of the historic Hawthorne facility. This wasn't just any building, it was a symbol of aerospace history, where Boeing once crafted the mighty 747 fuselages that would connect the world. Now, under Elon's leadership, it would become the birthplace of a new era in space exploration. The transformation of this facility tells a story of American ingenuity at its finest. Within these walls, thousands of engineers and technicians worked tirelessly, turning ambitious blueprints into reality. The Falcon 9 rockets took shape here, each one representing countless hours of innovation and determination. The Dragon capsules, designed to carry both cargo and human lives into the cosmos, were meticulously crafted in these very halls. This wasn't just a factory, it was a crucible of innovation where the impossible became possible. California's leadership recognized the potential. In a strategic move to secure this growing powerhouse, Hawthorne officials crafted a deal that seemed unbreakable at the time. Tax incentives were offered, including a modest annual business license fee cap of $260,000, a small price to pay for retaining what would become one of the most valuable aerospace companies in history. The agreement was set to last through 2022, a timeline that seemed far into the future when pen first met paper. But beneath the surface of this seemingly perfect partnership, tensions were brewing. The California dream, with its promise of innovation and prosperity, began to show its cracks. The state's regulatory framework, once designed to protect and nurture businesses, started feeling more like a stranglehold to companies pushing the boundaries of technology. High taxes, initially justified as investments in infrastructure and talent, began to look more like barriers to growth in Elon's eyes. The breaking point came gradually, then suddenly. Tesla's departure to Austin in 2021 wasn't just a corporate relocation, it was a warning shot across California's bow. The move signaled a fundamental shift in how technology companies viewed their relationship with the Golden State. Austin, with its growing tech ecosystem and business-friendly policies, offered more than just lower operating costs. It offered freedom to innovate without the constant shadow of regulatory oversight. Texas understood something that California seemed to have forgotten. The key to attracting and retaining innovative companies lies not just in having talented workers, but in creating an environment where those talents can flourish.